Okay, we're going to go ahead and look at how to write some of these polynomial equations that have some uglier roots. The last videos talked about what to do if the roots were relatively pretty. We're going to deal with some of the uglier ones. This one, first one's pretty bad. It has a -1 minus the square root of 5 for a root. So we're going to talk about how to deal with that first, and then the other ones as well have a little bit of ugly going on. So for that -1 minus the square root of 5, I need to realize that if -1 minus the square root of 5 is a root, then -1 plus the square root of 5 is also a root. So both of those are roots. And what I'm going to use is I'm going to use the sum of those roots to help me find B, and the product of those roots to help me find C, because I know anything that has a square root or an I in it had to come from a quadratic equation, because you had to use the quadratic formula to get those square roots and I's. So when I find the sum, I will add those up. -1 plus -1 is -2. And very conveniently, -5 plus square root of and positive square root of 5 would cancel out if I were adding them up. So that means my sum is just -2. And what this means is the value of B in my quadratic formula is the opposite of that, or 2. So B is always the opposite of my sum. Now when I'm looking for C, I'm going to take those same roots and I'm going to multiply them. Now technically when you multiply them, you should multiply out using the FOIL method, but I'm going to show you what happens here when I try using the FOIL method. I do -1 times -1, which is +1. Then I have -1 times this, which is a -1 square root of 5. Then when I multiply a negative square root of 5 through, a negative times a negative is a +1 square root of 5. And then when I do negative square root of 5 times positive square root of 5, that's negative square root of 25. But notice in the middle, a minus square root of 5 and a plus square root of 5, those cancel out. And that will happen every single time. So the truth is, when I go to multiply, the only thing I really have to worry about is multiplying the -1 times the -1, which gives me the +1. And then I also would need to multiply my negative square root of 5 and my positive square root of 5. The fact that it has a plus and a minus means those middle terms will always cancel out, and I can take the shortcut and basically get that far. And one more shortcut I could have taken is the square root of 25 was just 5, and the truth is the square root of 5 times the square root of 5 is always 5. The square root of 4 times the square root of 4 is always 4. The square root of 3 times the square root of 3 is always 3. So I could have taken several shortcuts and basically gotten to a +1 minus 5 very quickly, and then when I simplify that, that gives me the value of C. So C is the product itself, B is the opposite of the sum. So C equals -4. Now I'm going to have my quadratic equation here will be x squared. My B value is 2, so plus 2x. My C value is 4, so minus 4. Now the next thing I need to worry about is the -2. So that's going to be just an x plus 2. And since it has a multiplicity of 2, you could either write it twice or be a little bit quicker just to put an exponent of a square. The last thing that's a little bit of concern, I'm going to go up here and deal with it, is this 1/3. I could do an x minus 1/3, but we would prefer not to have a fraction. In fact, we don't want a fraction in my factored form generally. So I have to say, what can I multiply by to get rid of that fraction? I could distribute a 3 through to remove that fraction. So instead of writing that as an x minus 1/3, the way you'll usually see that written is as a 3x minus 1. So if you have something with a fraction, whether it's a linear or quadratic factor, generally you're going to multiply by that denominator to get rid of that fraction. And you notice you did have a total of 5 solutions, and I have a total of 5 x's. 2 here in my quadratic, another 2 here because of your multiplicity, 1 more there. So there's 5 x's to go with my 1, 2, 3, 4 because of the multiplicity, 5 solutions. Hope that helps you understand this a little bit. We'll work a couple more examples in the next video.